Yes, very good morning, children. So today we'll discuss the new chapter is called Redox Reaction. Look at here, Redox Reaction. Redox. So redox reaction. So in this case, what is redox reaction? If I want to say, I can say that any chemical reaction, I can write oxidation, and we can say that reduction takes place simultaneously. Oxidation reduction takes place simultaneously. The reaction is called redox reaction. Can you give me the example? Let us take one simple example. I'm taking, yes, let us take that. MnO4 minus plus, or we can say that Fe2 plus. I'm going with the presence of what is that acidic medium. It is converting into what is that Mn2 plus plus Fe2 plus. Now my questions are whether this reaction is redox reaction or not. Yes, the reaction is redox reaction. How to find out whether this reaction is redox or not? Very simple. Find out the change in oxidation state of each element. In the case of MnO4 minus, I can say the manganese is what plus 7 oxidation state. Here the manganese is what plus 2 oxidation state. I can say that the change in oxidation state is what 5. That means MnO4 minus become Mn2 plus. It is reduced. That means it is gained, or we can say as 5 electrons. Now Fe2 plus. Now Fe2 plus become what is it? Fe3 plus, that means it lost 1 electron. That means we can say what is redox reaction? Loss of electron and gain of electron takes place. Such reactions are redox reaction. A redox reaction, number of electrons gained, number of electron lost must be equal. Observe here, I can say that MnO4 minus becomes Mn2 plus, it is gained 5 electron. Fe2 plus becomes Fe3 plus, it is lost 1 electron. In a redox reaction, number of electrons gained, number of electron lost must be equal. So now what I am going to do? Just I want to cross multiply. When I am going to cross multiply, that is nothing but is called n factor. The n factor reverse of molar ratio. So what is n factor? N factor means number of electrons gained, number of electron lost per mole of the compound is called n factor. Now the MnO4 minus becomes Mn2 plus. It is gained, or we can say 5 electron. Fe2 plus becomes Fe3 plus. It is lost 1 electron. I can write that n factor of MnO4 minus is what? 5. N factor of, I can say that Fe2 plus is 1. Now I can say n factor reverse of molar ratio. So why sir you are saying that n factor reverse of molar ratio? What is the logic behind this? Because in a redox reaction, number of electrons gained, number of electron lost must be equal. So I am going to multiply this is 5. This is what 1. Therefore 1 into 5, 5 electron. 5 into 1, 5 electron. Now I have to balance this, and I am going to balance that. This become what? 5 Fe3 plus. Therefore 1 Mn2 plus. It is balanced. Now we have to balance the oxygen atom. Look at the medium is what? Acidic medium. The medium is acidic medium. Wherever the less number of oxygen, for each oxygen you have to add H2O molecule. Therefore 4 oxygen here. Therefore I add 4 H2O. Now I can make it. This is 8H plus over. Reaction is balanced. So that means what is the redox reaction? Number of electron gained, number of electron lost should be equal in redox reaction. And oxidation and reduction takes place simultaneously in a redox reaction. Even we can say as disproportionation reaction is example of redox reaction. So can you give me the example of disproportionation reaction? What is disproportionation reaction? Now I can write it disproportionation reaction. The disproportionation reaction is example of redox reaction. Let us take the example. We know that Cl2 plus I am taking sodium hydroxide. The medium is what? Hard. Obviously, what I am going to get as NaCl plus what? NaCl2 and then this plus H2O. Oh. Now this is the example of disproportionation reaction. What is the meaning? The same element has undergone oxidation as well as reduction. How we are telling that Cl2 undergone oxidation as well as reduction, and what logic behind this one? We know that Cl2 has 0 oxidation state. This is what NaCl is -1. In NaClO3 it's a +5. That means what I can say that in NaCl, chlorine is -1 oxidation state. NaClO3 it's a +5 oxidation state. That means 0 become what we can say -1. They gained what we can say 1 electron, and Cl2 become what we can say +5. That means they Last what we can say 5 electron. Last 5 electron, gain what we can say as a 1 electron. Please keep it in your mind. Then what could be the what we can say if I'm going to Cl2? In Cl2, what we can say in each chlorine, in per molecule of Cl2, we have 2 chlorine atoms. So each chlorine, what we can say, lost what we can say 1 electron or gained 1 electron. Suppose how am I writing that? Cl bond Cl. This is 0 oxidation state. This is 0 oxidation state. 0 become -1. 0 become -1. Therefore, the Cl2 becomes Cl minus means it is gained probably what we can say 2 electrons. And Cl 0 become +5. 0 become +5. Totally, how much electron it is lost into 2 is equal to what we can say 10 electrons. So therefore, if you want to make it, so you have to, this is systematic way. If you want to do the balancing, will be if you get 3 Cl, you may get it, you may get 6, or you can say NaOH, and you may get as 5, and this is going to come as what we can say 1. The many we can balance as 3H2. That's all. This is what the balanced equation. So the disproportionation reaction is example of redox reaction. But in examination point of view, what they will ask you? In examination point of view, what they will ask you, we are going with that one by one. First we will go as titration. So what is titration? You know that, very simple. In titration, I am going with that. We know this is burette. When you have the nose, you have seen the 11th standard. This is burette. And they may fill some solution. I can say that let us take, okay. Now some solution, I can say as unknown solution. Unknown concentration, I can say that. Now in this beaker, I am going to ask you to prepare what we can say 0.1 molar of sodium hydroxide in what we can say 200 ml. I am asking you. So 0.1 molar means what? We should know what is molarity. What is molarity? We can say that molarity is equal to the number of mole by what we can say volume of solution. That means 0.1 molar. 0.1 molar means what we can say 0.1 mole per liter. 0.1 mole. That means what I have to do 0.1 mole. 0.1 mole means what I have to do. Look at this. We know that mole. N is nothing but weight by molecular weight. Is what? Weight by molecular weight. And weight by molecular weight, what I am going to do? How many mole? 0.1 mole. 0.1 means what? I can say as 4 by 40. 4 by 40 is nothing but is what? 0.1. Right. Now you are dissolving into how much ml? Let us take it as 200 ml you are dissolving it. Right, I am asking you to make it 0.1 molar of sodium hydroxide solution. When you are making 0.1 molar means what? 0.1 mole. What do we can say? 0.1 molar of sodium hydroxide solution. So 0.1 mole, and what do we can say? 1000 ml of water. So obviously, what is the answer you are going to get it as will be 0.1 molar. In this 0.1 molar, you are taking from this what we can say 20 ml. 20 ml. I am adding here is what? 20 ml of NaOH is here. Here I am going to use what? Hydrochloric acid. That means what is titration? Titration means from known concentration finding strength of unknown solution is called titration. From known concentration. I know what is the concentration 20 ml of sodium hydroxide is 0.1 molar. Now I am going to here use indicator. What indicator I am going to use it? I can use it as phenolphthalein. I am using is what? Phenolphthalein indicator. Solution is what? Is a pink color. Now I keep on doing titration. Once pink color disappear, stop titration. Once pink color disappear, stop titration. I come to know what is the volume of hydrochloric acid used here. From this, now I can able to find out the strength of hydrochloric acid. Then what is titration? Titration means from known concentration finding strength of unknown solution. How is that? Now I can write the equation. Look at this. Now I can write it as sodium hydroxide means NaOH plus hydrochloric acid, which gives is what? NaCl plus H2O. Now we can write that as per law of gram equivalence, we can write that gram equivalent of NaOH is equal to, we can write that gram equivalent of hydrochloric acid. What we can say as gram equivalents, I can write that normality into volume. I can write N1 V1 is equal to is what? N2 V2. What is normality? I can say that N factor into molarity M1 V1. I can say that N factor into M2 into V2. What is molarity into volume? Number of moles. I can write that N factor into mole. I can write that N factor into mole. That's all. Now I can say that how much volume of sodium hydroxide used? 20 ml. What is the concentration? 0.1 molar. Look at this. Anyway, sodium hydroxide is monoacid base. N factor is 1. Therefore, molarity is equal to normality. Therefore, I can write 20 into 0.1. Here I am getting the volume at 20 ml. What is happening? Pink color disappear. Stop iteration. I can write 20 into what is that? N1. Here also hydrochloric acid, mono basic acid. Therefore, normality is equal to molarity. Therefore, I can write that N1 is nothing but, that means here I can take N2 is better. That means N2 is nothing but 0.1 normal, or we can say that 0.1 molar. Okay. This is called titration. In this titration, in exam, what they will ask? In exam, what they will ask? We will discuss one question. That question which gives the clear picture. Look at that. Now, I want to bring this. They are telling that 1 mole of ferrous oxalate. What is it? FeC2O4. Ferrous oxalate is oxidized by X mole of KMnO4 in acidic medium. X mole of KMnO4 in acidic medium. Find the value of X. Now, what is that KMnO4? This is ferrous oxide. First, write the equation. You should know what product you are going to get. Then writing that MnO4 minus plus FeC2O4 gives Mn2 plus Fe3 plus C2. Look at this ferrous oxalate, because MnO4 minus is oxidizing agent. What medium? Acidic medium. Whenever acidic medium means MnO4 minus become Mn2 plus, and ferrous oxalate, in ferrous oxalate FeC2O4 become Fe3 plus and CO2. Now you want to find out what is the N factor. How to find out N factor? Number of electron gain, number of electron lost per molecule or per mole is called the N factor. Now I can say MnO4 minus. I can say that here X is equal to plus 7. Here is what 9 is X is equal to plus 2. How much electron it gain? I can say as it's a 5 electron. Now I can say MnO4 minus N factor is what we can say as 5 is the N factor. Okay, fine, we got the answer. Now we want to find out what could be the N factor of FeC2O4. That means ferrous, here is what 2 plus. 2 plus becomes what 3 plus. That means they lost 1 electron. At the same time, oxalate. Oxalate means what I can write? C double bond O minus. I can write that C double bond O minus. It becomes is what CO2. Now we want to find out what is the oxidation state of carbon. Now I can write it, each carbon, this is what plus 3 state. This also is what plus 3 state. So how we are going to say each carbon is plus 3 state? Very simple. I can write 2x I can say that minus 8 is equal to is what? Minus 2. Therefore, 2x is equal to 6. X is equal to is plus 3. Now 2x means what? These two carbon. Minus 2. Totally what we can say? Minus 8 is equal to charge also minus 2. Therefore, is what we can say? 2x minus 8 is equal to minus 2. Therefore, 2x equal to 6. X is equal to plus 3. That means each carbon has plus 3 oxidation state. What about in the case of here? X is equal to plus 4. Now plus 3 become plus 4, plus 3 become plus 4. That means per molecule of C2O4 2 minus, you have two carbon atom. Each carbon, what we can say, lost one electron. Total number of electron lost per molecule of C2O4 2 minus becomes CO2 is what? 2. Why? Here we can say that 2x equal to 6, x is equal to 4. What about 2x is equal to 8 or not? The difference is what? 2. Therefore, the n factor of C2O4 2 minus becomes CO2 is what? 2. At the same time, in the ferrous oxidate, Fe2 plus becomes Fe3 plus C2O4 2 minus becomes CO2. So, total number of electron lost per mole of FeC2O4 is what? 3 is the n factor. Now, come to the point. Now, as per the what we can say, I can write n factor of KMnO4. I can write it as is 5. I can write that n factor of FeC2O4 is what? 3. Now, what is the question now? We know that as per the law of gram equivalence, now I want to clean this. Look at that, what they are trying to say. As per the law of gram equivalence, what the law of gram equivalence says, as I told you that, I have given that mole into n factor is equal to, I can take mole into n factor, depends on the condition, we can write it. Look at this, let us take this is ferrous oxide. Moles of ferrous oxide is 1. What is the n factor of ferrous oxide is 3. Now what is the mole of KMnO4? I given x. What is the n factor is 5. Therefore x is equal to is what? 3 by 5. That means you can say as a 0.6 mole. That's all. This is what the JEE mains question may expect like this. Can we go one more question? Look at this. Suppose they are asking like this. Find out the volume of. Now, can I clean this? I'm going to clean this. Find the volume of. Find the volume of 0.1 molar K2Cr2O7 is required to react completely with. Question is find the volume of 0.1 molar K2Cr2O7 is required to react completely with 50 ml of 0.2 molar of 50 ml of 0.2 molar of FeC2O4 ferrous oxalate in acidic medium. First we should write the equation. What is K2Cr2O7? So what is going to happen? Write it. We can write as Cr2O7 2 minus plus we know that FeC2O4 medium is what? Acidic medium. It becomes a Cr3 plus Fe3 plus is what? CO2. This was the equation. You should know the equation. Now, what is the n factor of Cr2O7 2 minus? Just you want to find out. That means we can write the Cr double bond O like this. This is the K2Cr2. That means Cr2O7 2 minus. The medium is acidic. It becomes what? Cr3 plus. Please observe. In this per molecule, how many chromium is there? 2 chromium. Each chromium is what? This is plus 6 state. This is plus 6 state. Plus 6 become plus 3. Plus 6 become plus. That means I can write 2x equal to 12. Here is what? X is equal to plus 3. Therefore, the 2 chromium atom is involved in this one. Therefore, per molecule 2 chromium is there. Therefore, 2x equal to 12. Here also is what? 2x equal to 6. That means I can say plus 3 plus 6 become plus 3. They gain 3 electron. Plus 6 become plus 3, again 3 electron. Total number of electron gained per molecule of per mole of Cr2O7 2 minus is what? I can say as 6 electron. Therefore, n factor of Cr2O7 2 minus is what? 6. And we have learned already FeC2O4. The n factor is what we can say 3. Now we can write it as per the law of grand equivalence. We can write it as, look at that. I'll take it n1 into v1 of what is that? FeC2O4. Nothing but n2 v2 is nothing but is what? Cr2O7 2 minus. What they are asking? Find the volume they are asking that. So now in this, how much they are given? 50 ml of 0.2 molar. So what is normality? We can write molarity into n factor. That means I can write n factor into molarity into volume. Same thing. What is the n factor of ferrous oxalate? 3. What is the molarity is given? 0.2 molar. This is what 50 ml. Volume will take this in terms of ml will take. Now normality. So that is normality. N factor into molarity. They gave molarity. N factor is what? I can here also get it. N factor. M2 into V2. What is N factor of K2CH2O7? 6. This will be is what? 0.1. So I want to find out V2. So now I can cancel it off. Look at this, this and this. Now obviously what is going to happen? This and this will be cancelled. 0.2 by 0.1 is what is nothing but as a 2 cancelled off. Therefore, so these type of questions we may expect in JEE mains. Now one more question will go. Look at this next one, sir. What about the volume strength of hydrogen peroxide? How to find out the volume strength of hydrogen peroxide? Look at this. Now I want to clear this. Volume strength of hydrogen peroxide. Generally, look at this. Volume strength of hydrogen peroxide. So how to find out the volume strength of hydrogen peroxide? Generally they will do at STP, because we know that hydrogen peroxide is unstable. Now what I am going to do? O bond O, here is H and here is what? H and P. So this undergone, what we can say, because of O bond length is higher, easily breakable because of the repulsion between the non-bonding electron pairs. It undergone disproportionation reaction as H2O plus O2. I want to balance that, yes, which I am going to consider as at STP. I can say that 1 liter of solution is there. When the 1 liter of solution is there, now the measure of volume strength they may find out based on the how much of oxygen gas liberated. Now I can say that 2 mole of H2O2 liberate, what we can say 1 mole. You say that 1 mole at STP means what? Oxygen gas I can say as 22.4 liters. I can say 22.4 liters is obtained from 2 moles of hydrogen peroxide. Suppose if it is V liter of oxygen gas obtained from how many mole? I told you that 22.4 liter of O2 obtained from 2 mole of hydrogen peroxide. Suppose V liter of O2 obtained from, I can say that 2 divided by 22.4 into V mole of what is that? H2. Now this I simplify, which I am going to get is what? 11.2. Now I come to know V divided by 11.2 mole of H2O2. What is molarity? Number of moles by volume of solution. What is volume of solution here? 1 liter of solution. Therefore I can write that molarity is equal, number of moles is what? V by 11.2. That's all. Whenever liter is equal into 1 liter, obviously this is the molarity. Then what about normality? Look at this, I can write that normality is equal to N factor into molarity. What is here the N factor? Look at this. We can say that O2 2 minus gives what is that O2 gas. Therefore, we can write 2x is equal to minus 2. We can say that 2x equal to 0. Difference is what 2. Therefore, n factor is 2. H2O2 become O2. N factor is 2. That means I can say here 2 into what is molarity? B by 11.2. Therefore, I am going to get B by 5.6 is nothing but normality. So, what is here B? The B is nothing but the 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 oxygen gas comes out in terms of liter. Suppose if I am telling, what you can say, 11.2 volume of H2O2. What is the meaning of 11.2 volume of H2O2 means? We can able to find out molarity. That means M is equal to 11.2 by 11.2 is equal to 1 molar. 1 molar means what? 1 mole in 1 liter of solution. 1 mole means what? 34 gram of hydrogen peroxide. So 34 gram hydrogen peroxide present in what we can say 1 liter of solution means that means 3.4 gram in 100 ml of solution. That means how much percent? 3.4% is nothing but 11.2 volume strength of hydrogen peroxide. This is what you may expect in the examination. Now, in this, what type of question they are going to ask you? Look at this. Now, I want to play this. I think now I will go with that. $20 ml of hydrogen peroxide is completely react with 40 ml of 0.2 molar KMnO4 acidic medium. 20 ml of hydrogen peroxide is completely reacted with 40 ml of 0.2 molar of KMnO4 acidic medium. Find volume strength of H2O. That's a question. Now, first we should know what is the reaction. So, what is the reaction? We can say that KMnO4 plus H2O2. What you are going to get as Mn2 plus, because medium is acidic, plus O2 gas liberated. Why? KMnO4 is oxidizing agent. Because hydrogen peroxide can act as the oxidizing as well as reducing agent. As per the law of gram equivalence, we can say that normality into volume, I can write it as, look at this, for hydrogen peroxide, N1 into B1 is equal to N2 B2 for KMnO4. Now, what is the volume is given 20 ml. Normality can be witness a volume strength is what? B by 5.6 is equal to, what is the normality? N factor into molarity. What is the N factor of KMnO4? MnO4, that means this is plus 7 plus 2. N factor is 5. What is the molarity? 0.2. I can say is what? 40 ml. This also is what? ml will be cancelled. Right? Now, from this, look at this. Now, here, this and this going to come as what? 2. Now 5 2s are 10. That means 2 into 5.6 V. V is equal to what? That's all. So 11.2 means what could be the molarity of hydrogen peroxide? Just now we have discussed. That's all. Molarity is what? 1 molar of 20 ml of hydrogen peroxide is completely reactive. That's what they're asking the examination. These type of questions you may expect definitely in JEE. Look at this. Now next is iodometry reaction. So what is iodometry? See, iodometry is very simple. Now I can say the iodometry is also type of redox titration. What they will do, estimation of oxidizing agent. What they will do, for example, I am taking, let us take one simple example. I am taking as MnO4 minus. I can say this is impure. I can say this is impure MnO4 minus. They are going to add that Ki excess of Ki they will add. So the medium could be is what as acidic medium they will. When they're taking an acidic medium, what is going to happen? It becomes Mn2 plus, then what liberate I2 liberate plus H2O. The liberated I2 they titrate with what is going to form as here the n factor of I2 become I minus n factor is, look at this, I2 become I minus, that means 2I minus, I can write that n factor is 2. Now the n factor of, look at this, Na2 S2 O3 become as Na2 S4 O6. I can write 2x is equal to 4. Here is what 4x is equal to 10. But how many sulfur involved? 2 sulfur only. Therefore I can write 2x which is equal to 5. So the n factor is what 1. N factor reverse of molar ratio here is 1. Here is what 2. That means what they will do, they will take the impure KMnO4, add excess of K, I2 liberated. Whatever the I2 liberate, titrate against standard solution of Na2S2O3. What is the meaning of standard solution? The standard solution means the whose concentration is known. Now I want to balance it. Obviously, I minus B combined n factor is 1. MnO4 minus n factor is what? 5. Now I am going to get is what? 5 by 2. I got it. That means I can say that 2.5 more. Now I want to give you, from this I want to give you a simple question. What is the question? Because the same thing only. I'm going to take it as 1.58 gram of, that means impure KMnO4 treated with excess of Ki. Then I2 liberate I2 liberated. It is required it is required 50 ml of 0.1 molar Na2S2, 50 ml of 0.1 molar Na2S2O3. Find the I2 liberated, and it is required 50 ml of 0.1 molar Na2S2O3 for the endpoint Find the percentage purity of this is the equation. We don't know how much of KMnO4 is there, we don't know that. We know that what is the KMnO4 molecular mass? KMnO4 molecular mass is 158 gram per mole. They said 1.58 gram. Observe carefully. We can say that 2.5 mole obtained from 1 mole of KMnO4. We can say 2 mole required, 1 mole. 2 mole required is what? 1 mole. Now, what I am trying to say, right? Listen, 50 ml of 0.1 molar. That means this is 2 mole required, 1 mole. Now the question is 50 into 0.1. I can say that 50 into 0.1 means I can say 5 millimole. 2 mole required, 1 mole. 5 millimole required, 2.5 millimole. Obviously 2.5 mole required 1 mole. Here how much you got it? 2.5 millimole. 2.5 millimole means what I can say here? 1 millimole only. So 1 millimole means how many gram? That means 1 into 10 power minus 3 into what is that? 158. I can say that 0.158 gram only. So out of what we can say 1.58 gram, how much actually came out of this percent? 0.158. That means I can write it as 0.158 divided by 1.58 into what is that? 100. That is nothing but the percentage purity. That means you can write 0.158 divided by 1.58. That is what? 0.1 into 100. That is what? 10% is the answer. So this is what in the iodometry estimation of oxidation. We can use K2Cr2. We can use copper sulfate. So these are all the example of what we can say as the iodometry titration. Can you solve one more question? Look at this. I want to give you one more question. We'll go with that as one minute. We'll go with that one nice question. Yeah. Question is 50 ml of an aqueous solution of H2O2 treated with rather than listen. This is a nice question. Okay. I'll go with that. 8.7 gram of MnO2 is treated with corn HCl. Cl2 is liberated. Cl2 is liberated, and it is passed excess of Ka, I2 liberated, and it is required is required 20 ml of 0.1 molar Na2S2O3 for the endpoint. Find the percentage purity of MnO2. That's all. This is what they are asking. Find the percentage purity of MnO2. So now what are you going to do? Very simple. Take the reaction. MnO2 plus NaHCl, MnCl2 plus Cl2 gas liberated plus H2O. Now we can take it as 4. That means you are going to get it as 2H2O. Now this Cl2 is passing to Ka excess, I2. Therefore, this I2 we are going to have as n factor is what? As this is 2 n factor. Therefore, I2 is 2 and Na2 is 2, the n factor is 1. N factor reverse of what? This is what the equation. Now, MnO2, how much they gave? Gram of 8.7 gram. It's a impure. Assume that the impurities are inert impurity, does not react with any other. That's what you have to think about. Ready? Now what they have given is, as per the equation, 2 mole react 1 mole, 1 mole obtained from 1 mole, 1 mole obtained from 1 mole. Now as per the question is what? 20 into 0.1, I can say that 2 millimole. That means 2 millimole means here is what? 1 millimole. So obviously what? 1 mole from 1 mole, 1 millimole, 1 millimole upend from 1 millimole of Cl2. Here also what 1 millimole is upend from what is it? 1 millimole of human O2. That means 1 millimole means what we can say that 87 into 10 power minus 3. Nothing but what we can say as how much we are given 8.7 gram. That's all. So now we can say that how much we have 87 divided by you can say 1% is the answer. 1% is percentage purity. That's all. So these type of questions you may expect in the case of what JEE mains kind of. That's all I can say from that side. Now, next we will go with that. Another thing is so Redox part is over. Now we will go with that. The concept is called, as I told you, that metallurgy. So what is metallurgy? Listen to me. We'll go with that metallurgy. Now, in this metallurgy, I am going with that. See the flow chart. I can say that ore. That means we can say that extraction of metal from its ore is called metallurgy. I can say ore. Next, we are going to do a process is called the concentration of the ore. What is the concentration? There are 4 important processes are there. One will be gravity separation. Next is I am going with froth flotation process. Then we have the magnetic separation. Next we are having is what leaching process. So once you got what is the ore? Ore has impurity. So we have to do the concentrate the ore. Then there are 4 processes. Generally what they will do? The froth flotation process they will use only sulfide ore. And magnetic separation they will use for whether the ore has magnetic property or impurity has the magnetic property can be purified. And leaching process generally we can go for the leaching means the principle the ore must be soluble in suitable solvent, that is the principle. And the froth flotation process principle is what? The ore and impurity must be what we can say different adsorption process. For example, sulfide ore adsorbed in pine oil. Ore is adsorbed by impurity is adsorbed by what we can say water molecule. Gravity separation density principle, carbonate and oxide ore can be purified by gravity separation. Fine. Once we give the concentration, then the process is called convert into oxidation. What is that? We can say as roasting. Another one is called calcination. That means roasting and calcination, why we are doing is because converting into oxide ore. Why we are converting into oxide ore? Because it's easy to reduce it. Look at this. Now in this case, there are cases one by one. Once you got the metal oxides, there are process. What is the metal oxides? One will be, we'll go with that high reactive metal oxide category. High reactive metal oxide. Here the moderate reactive metal oxide. And here is what low reactive metal oxide category. Because the categories high reactive metal oxide, moderate reactive metal oxide, and low reactive metal oxides. Once you after calcination roasting for sulfide ore, this will be what carbonate ore. Okay, fine. And one more thing, for high reactive metal oxide, they may go for the electrolysis process. That's all. Oxide, what they will take go for the electrolytic process they go. For moderate reactive metal oxide, they may go for the carbon reduction. For the low reactive metal oxide, they may go for gentle heating, or I can say that the sulfide ore of copper, lead, and mercury. Sulfide ore of copper, lead, and mercury. They undergone self reduction, which gives the corresponding what we can say metal. Once you got the metal from these three processes, metal, metal, metal. So next we have to do the refining process. Generally, the better refining is called electrolytic refinement. So that means ore, concentration of ore, fourth process. Once if we do that, depends on the nature of ore. If it is carbonate ore, calcination. If it is sulfide ore, roasting. Over. Then after that, once you got it, go for the once you convert into oxide ore. Depends on the nature of the metal oxide. If it is moderate reactive metal oxide, go for the carbon reduction or carbon monoxide reduction that can be explained as an Elingham diagram. Elingham diagram which is the better reducing agent. That also we will discuss. For high reactive metal oxide, go for the electrolytic reduction, and low reactive metal oxide go for the gentle reduction. Gentle heating is enough because low reactive metal oxide decompose it easily at lower temperature. Fine. Now let us take some. We'll go some example after discuss about ore, then concentration process. Then we'll take example. I'll come to you. Now I want to discuss with that. Now look at this. Ore. What are all ore? We'll go with it one by one. I can write bauxite, whether it is hydroxide as well as oxide ore. Al2O3.2H2 is called bauxite. Now FeCO3, siderite, then CuCO3.CuOH twice. I can say malachite. I can write that CuFeS2, copper pyrite. Now, next I can go ZNS, zinc blend, BBS, galena, ZnCO3, calamine, Ag2S, argentite, SnO2, cassiterite, BbSO4, anglesite, BbCO3, cerussite. So these are all, and very important thing is Na3Alf6, cryolite, CaF2, fluorspar. So these are all the ore. In this ore, we are going one by one. First, we'll go leaching process. In leaching process, I'm going with bauxite. In leaching process, what they will do? Look at that. I can say that in leaching process, I'm taking as Al2O3 dot SiO2 dot Fe2O3 dot TiO2. This is impurity is called GAN. So now in this, what I'm going to add NaOH. When I'm adding NaOH, what is happening? Al2O3 becomes forming complex. AlOH4 minus plus I'm getting is Na2SiO3 plus FeOH twice plus TiOH4, and there's a precipitate. So these two removed as a precipitate. Now I want to get the precipitation of this, so that I am going to choose what we can say the mild acid carbon dioxide gas, CO2. Why CO2 I am choosing? Excess of NaOH get neutralized. At the same time, AlOH4 minus can precipitate as AlOH twice. Now I got it. Now if I am going for the hydroxide ore, I can do the calcination process heating. I got Al2O3. Now I got this. Now it's a high reactive metal oxides. I have to go for the electrolytic detection. That process is called Hall's process. But in the case of Al2O3, because for electrolytic detection, I can say that it is required, the huge amount of temperature is required. So when a huge amount of temperature means what? For example, it's required 2000 Kelvin. But once the aluminum is deposited, what we can say anode, the boiling point of aluminum is, I can say, 1200 Kelvin. But how much temperature supplying that? 2000 Kelvin. So once the 2000 Kelvin means that most of the aluminum gets evaporated, therefore a huge loss will be there. To overcome that, they are going to add what we can say cryolite and fluorspar. Why they are adding? To decrease the melting point of the mixture. Right? So when I'm going to add that, purpose of adding Na3Al F6Y, because to decrease the melting point of the mixture, at the same time, what we can say, brings good conductivity. So therefore, that's called Hall's process. Therefore, in that, what they are going to do? They are adding. Therefore, they will use anode as, I can say, as graphite. Or you can say as the carbon rod is anode, and cathode is iron steel. They will use. So now what will happen? Al 3 plus 3 electron gives Al, deposited what we can say as cathode, and anode is nothing but very simple. C plus O2 minus, may get us here CO. C plus what we can say 2O2 minus here, when we get is what? CO. That means carbon monoxide and carbon dioxide liberated at what we can say anode. So this is called electrolytic process of aluminum. Aluminum deposited. Oh, it's called Hall's process. And now got the next time taking. Look at that. Next, in the case of now, I'm going with. I'll go with that. Ag to S. Whether we can go for the flotation process or we can go for the leaching process. I'm taking NaCN. Purpose of using NaCN is what? To make soluble complex in presence of air. Will form as AgCN twice minus plus SO4 2 minus. It forms soluble complex. This soluble complex of AgCN twice minus zinc. Why? High reactive metal can displace what we can say lower reactive metal in that salt form. Therefore, this is the soluble complex. Zinc, obviously what? It's a redox reaction. You may get it as Zn CN4 2 minus plus Ag. Got it? This is called impure Ag. Let the what we can say pure Ag go for the electrolytic refining. Now we can say that anode and cathode. Anode, cathode, what we can say? Impure Ag. Here, pure Ag acts as a what? Cathode. What is electrolytic solution? AgNO3 acidified. So, fine. Now, when you cause electricity, what will happen? This is going to dissolve. That means Ag become what is that? Ag plus electron. Therefore, this Ag is going to deposit what we can say as here Ag. So this process, if we keep on doing that, we may get to 99.9%. This process is called electrolytic refining process. Now, next come to the point about. So now this is about electrolytic and low reactive metal. Now, in the case of copper, look at this. In the case of CuFeS2. What they will do? FF. What is FF? Sulfide ore flotation process. Fine oil acts as what? Frothing agent. And sodium methyl xanthate acts as a what? Collector. Sodium cyanide acts as a depressant. So once got it, we go with that CuFeS2. Roasting. O2 you may get as partial Cu2S and Cu2O. And what is that? FeO. This FeO can be removed by adding SiO2 silica. Form is a slag, FeSiO3. and remaining will be as here small amount of in this one Cu2s plus FeS is called copper mat. Now when these two, now I told you these two undergone self reduction gives Cu plus SO2. It's called blister copper. Now this they go for what process? Electrolytic refining. Same thing. Anode impure Cu, cathode pure Cu. Now what will happen? Cu become Cu2 plus 2 electron. Therefore this Cu2 plus only deposit. You may get anode met. You may get anode met is means what? Impurity. That they got gold or silver will be present in that. That's all. Now come to the point of Eddingham diagram. So what is the Eddingham diagram gives information? Look at this. Now in the Eddingham diagram, which we can say that which is better reducing agent based on delta G naught values. Based on is what? Delta G naught value. Now come to that. Listen. Now let us take that. What Eddingham diagram talks about that. See, gives based on thermodynamical, they consider that order what we can say as the equilibrium reaction you consider. We draw the graph versus delta G naught of formation. Let us take, I can take that delta G naught versus temperature. Now I can take it all formation of Cu plus O2, I can say that Cu2O, I can say that Fe plus O2 gives FeO, I can say that Zn plus O2, I can say that ZnO, and Al plus O2 gives Al2O3. Now this will be what? Mg plus O2 Mg. Please observe here. I can say this is minus 700, minus 600, minus 300, minus 200, minus what we can this will be what 0. Above this line, they are unstable. They are what we can say unstable. They decompose it. So the meaning is what? Look at this. This is the point I can say. Let us take approximately as 1500. Look at this. Now, below 1500 Kelvin, Mg acts as a very good reducing agent. How is that? Look at this. I can write below 1500 Kelvin. Below 1500 Kelvin, I can write that Mg plus Al2O3 gives MgO plus Al. Why is that? Because below 1500 Kelvin, the Mg is lower point. That means I can say that formation is what we can say minus 700. That means Mg become MgO is minus 700 and Al become Al2O3. But we want what? Al2O3 become Al. Therefore, reverse of this. Therefore, minus 700 plus 600 delta G overall becomes what? Minus 100. Therefore, reaction is spontaneous. Suppose at 500 Kelvin, reaction attains equilibrium. Above 1500 Kelvin, I can say that Al plus MgO gives Al2O3 plus Mg. I can say that above 1500 Kelvin, I can say that aluminium is act as a very good reducing it. That means which and all is lower the line, they are very good what we can say reducing it compared to the above the line. That's what the information given by Eddingham diagram. Now come to the point. In this, how we are going to say that the carbon or carbon monoxide is better reducing agent on what logic? Look at that same logic of Eddingham diagram. Look at that. Now, you can say listen, let us take the example of ZNS zinc blend. We'll know what is the process. FF ZNS roasting. You may get is what? ZNO plus SO2. We got zinc oxide. What is the nature of zinc oxide? It is a moderate reactive metal. I have to go for the carbon reduction process. Look at this how. I will tell you that. same temperature. Here delta G naught. I can say that C plus O2 CO2 2C plus O2 gives 2CO. Now I can take it as CO plus half O2 gives CO2. Zn plus O2 Zn. Look at this is the one. I can say approximately 1000. Look at this. Below 1000 Kelvin, none of them cannot act as a reducing. Why? Because up to this, look at this point, right? All three will be above of Z and O. Therefore, up to 1100 Kelvin, Z and O cannot be reduced by anything. But look at this, if it is above 1000 Kelvin, the carbon will be below the line of this. Therefore, obviously, what will happen? Up to what we can say, or we can say below 1100 Kelvin, I can say that Zn ZnO plus C, which gives Zn plus CO, non-spontaneous. At what we can say 1100 Kelvin, reaction at equilibrium. If it is above 1100 Kelvin, I can say Zn plus C, which gives Zn plus what is that CO. Reaction is what? Spontaneous. This is called Ellingham diagram. So the Ellingham diagram, which gives information about which is the better reducing agent and what logic based on this diagram. So this is the temperature at which 1100 Kelvin. So at both at equilibrium, above 1100 Kelvin reaction is spontaneous, below 1000 Kelvin reaction is what? Non-spontaneous. This is what the Ellingham diagram. But whatever the temperature it is, whether it is 1000 or above 1000, CO cannot. These two are cannot act as a reducing agent of this. That's all. So this is the logic of what we can say that Ellingham diagram. Even we can go with that. Even look at this. Observe that. Now in the case of even gold also go with the what we can cyanide process. Look at this. AU. Really is what? Minus formation of soluble complex. This AU together with what is that? It's all. This is the logic of what we can say as the metallurgy process. Now, next is, so what is chromatography technique? What is chromatography? Before going chromatography, we'll discuss about Geldal method. The Geldal method which gives the clear cut idea. Let us take, they are telling that I'll from the question I'll discuss with you. Geldal method. Look at this. 1.4 gram of organic compound containing nitrogen heated ammonia liberated it is required 60 ml of 0.1 molar H2SO4 solution for neutralization. excess of acids was neutralized by 0.1 molar of 20 ml of NaOH. Find percentage nitrogen in organic compound. This was a question. 1.4 gram of organic compound heated, ammonia liberated, and it is required 60 ml of 0.1 molar hydrochloric H2SO4 solution for complete neutralization. The excess of acid was neutralized by 20 ml of 0.1 molar sodium hydroxide. Find the percentage nitrogen of organic compound. That was the question. It's a very good question. So first you should write the equation, then you'll go one by one. First, organic compound, heated, NH3 comes out. Now this NH3 plus H2SO4 twice SO4. Now balance it to gain the excess of acids. Let's do it. Now come to that. As per the equation, 2 mole required 1 mole required 3 mole. I don't know how much of sulfuric acid react with ammonia, but I know how much of sodium hydroxide react with the sulfuric acid. I know. Totally, how much is there sulfuric acid? 6 millimole. What about sodium hydroxide? They gave 20 ml of 0.1 molar. Two millimole. That means 2 mole react 1 mole. 2 millimole react 1 millimole. That means out of 6 millimole, 1 millimole react sodium hydroxide. Remaining how many millimole? 5 millimole. That means 1 react to 5 millimole of sulfuric acid react with 10 millimole. I have 10 millimole of ammonia is there. So 10 millimole of ammonia, come to the point, listen. Now we can say that 1 mole of ammonia has 14 gram of nitrogen, 10 power minus 3 into 10 mole of NH3 has how many gram? 10 power minus 2 into 14 by, or we can say weight of organic compound is 1.4 into 100 is nothing but 10%. It's called Geldahl method. And one more thing, Geldahl method we can able to give it is only for nitrogen. Aniline can give Geldahl method. Pyridine does not give. Azo compound does not give. The ring containing nitrogen does not give what we can say Geldahl method. That's all. These are all about Geldahl method. Now, listen. Next, chromatographic technique. So, what is chromatography? Very simple. The chromatography principle based on adsorption and solubility. Chromatography. Adsorption plus solubility. Absorption plus solubility. Let's take that. Listen. In that they will say TLC chapter. They will say, what is TLC chapter? Look at this. This solvent is there. They'll give the TLC plate up to down here. Here they may keep the spot 1, 2, 3. The solvent is on mobile phase. Here TLC plate is there. This is solvent will move up to this. You can say this is one spot. This is one, and this is. Let us make this is A, B, C. That means we can say in TLC plate, which is top of it, that is less absorbed by silica gel. In column chromatography, that will come first. I can say A, B, C. In TLC, which is in bottom, C. This is in bottom. This is C. This is what B. This is what A. So in TLC is above. I can say that in column that will come first. So to get the C, you should increase the polarity. Why? Because the system is made up of 30% of ethyl acetate plus hexane. So the A will be getting, I can say, approximately 10% of ethyl acetate plus hexane. You may correct the fraction, keep it separately. B you may get as 20% of ethyl acetate plus hexane. And C will be, you may get 30% of ethyl acetate. Increase the polarity. Why? To soluble the compound C. So this is a different bands are there. Therefore, the column chromatography and thin layer chromatography both are almost same, but this is against the gravity, this is towards the gravity. So therefore, in TLC, which is top of it, that will come first in column chromatography. That is less absorbed by silica gel. That is what? Less absorbed by silica gel. This is about the column chromatography as well as TLC. Now next will be very interesting point, surface chemistry. In surface chemistry, what and all we are going to learn very simple. Adsorption, we know that. See, surface chemistry. Very simple. Adsorption. You go with physical adsorption, chemical adsorption. Physical adsorption, no activation energy required. Chemical adsorption, activation energy required. For physical adsorption, this is what we can say as in physical adsorption. Look at this. This is what physical adsorption. Maximum was P, temperature is 1, P1, P2, P. This is called the friendly adsorption isotherm. X by M versus P. Suppose in the case, observe that in the case of physical adsorption, listen, X by M versus Y equals P. That's all. In the case of physical adsorption, temperature increases, X by M is keep on decreasing. What is X by M? X is mass of adsorbate, M is mass of adsorbent. Decreases for physical adsorption. For chemical adsorption, it may reaches. At a point, then again what we can say decreases because already it's adsorbed. Adsorption reversible process. Physical adsorption reversible, chemical adsorption irreversible due to formation of compounds. Chemical adsorption highly exothermic nature. Physical adsorption is less exothermic in nature. Adsorption is always exothermic. Delta G is negative, but entropy is what? Negative. Delta H is what? Negative. Now we can say that the friendly adsorption isotherm X by M is equal to K, P, M by M. That's all. The Kn depends on nature of gas, nature of adsorbent and temperature. That's all. And especially the very important point about if I want to say, I want to go with that colloids. In colloids, I want to go with the coagulation. So what is coagulation? Listen. Coagulation means very simple. In colloids, let us take and the E here. Colloids I can say positive, and then here I am taking is what negative collides. If I am going to add positive colloid means I am going to electrolyte NaCl. Here also I am going to add NaCl. Now Na plus and Cl minus. Here is what Na plus and Cl minus. This is electrolyte. This is electrolyte. I am going to add. In positive colloids, the electrolyte, the negative part responsible for coagulation. Coagulation means precipitation. In negative colloids, the positive part of electrolyte responsible for coagulation. That means when the electrolyte is added to the colloids, what takes place? Precipitation takes place. Here, if we want to discuss, there is a rule is called Hardy-Squeeze rule. What is Hardy-Squeeze rule? Let us take the negative colloids of arsenic sulfide and take AS2S. We are taking this is negative colloid. They are taking that negative colloid means what is responsible for that we can say as positive part of electrolyte. Let us take they are taking NaCN, they are taking CaCl2, they are taking is what? Al2, S44 thrice. So which will among these three they are going to add each of arsenic salt, which is coagulate faster. We should go with the charge of the cation. Here will be what we can say Na plus, we can say that Ca2 plus, here we can say that Al3 plus. High charge easily coagulate. High charge easily coagulate. That means I can say that Al3 plus, then Ca2 plus, then what we can say Na plus is called the coagulating power, and the coagulating value is high for Na plus than Ca2 plus. This should be Al3 plus. Higher coagulating power, less flacculating value. Fine. What about in the case of, look at this. Now, in the case of suppose we are taking as the positive colloids, which is going to coagulate faster. Let us take as here I am taking as, I'll go with that positive colloid. So I am taking as K4, Fe, CN6, Na3, PO4, Ca, SO4, NaCl. So in positive colloid, which part is responsible for coagulation means the negative part. Negative part is what here we can say that Fe, Cl6 4 minus, go with only charge, then PO4 3 minus, then we can say that SO4 2 minus, then is what Cl minus. So now the high charge will easily coagulate. Don't see the oxidation state of here ion. See the charge of the anion. So 4 minus, 3 minus, 2 minus means this is what order of the coagulating power of anion. Therefore, this will coagulate faster than these three, which has the high flacculating value of anion Cl minus. So this is about colloids. So whatever catalyst already we have discussed in the chemical kinetics, and last one very simple polymers. Yes, and Mary, polymers we go with that. Generally, what they will ask you thermosetting polymer and thermoplastic fibers and glyptol and we go what is a glyptol uses and go for terpene and Buna N rubber and Buna S rubber. What is the uses? That's what they will ask you, especially in the polymers. Now we'll go one important point is about the splitting of d orbital. Just I want to give you some idea about that. Once that is over, our chemistry part is done. Splitting of d orbital of what we can octahedral complex. We can go with that. Listen. If I complete that, our entire the chemistry session is over. That means you have done of 1 month of class. So now I can say that before going to that, listen. This is octahedral environment. How that develops. I can say this is Z, this is X, this is what we can say as Y-axis. That means the ligands are approaching along the axis. As per the crystal field theory, what we can say that ligands are considered as a point charge. When ligands are approaching, look at this. Slowly they increase energy. Look at this. Now, I'll try to explain you. The d orbital just split into two energy levels. Why? Why? Look this, the ligands are approaching along the axis. We know that along the axis means we can say that dx square minus y square and what dz square. So these two only is present along the axis. So if the electron is present in the what the single atom of metal, obviously these two orbitals are repelled more as compared to these three orbitals. Therefore, what is happening? Two orbitals are going up and three orbitals are only we can say the coming down to stabilize the orbitals, or we can say barycenter. This is called barycenter. So this is nothing but as 3 by 5 delta O, this much amount of energy increases and this much amount of energy increases minus 2 by 5 delta O. This is called crystal field splitting pattern of delta O. So what I am trying to say, look at this in this case. Now there are 5d orbitals. We know that CFT, the ligands are considered point charges. That means the metal and ligands, the purely what we consider ionic nature. So once ligands are approaches, so obviously it loses degeneration, it goes about higher energy level. Then still the after the environment comes in metal has electron. So the ligands are approaching along the axis. So which orbital present along the axis? Dx square minus y square dz square. That will repel more as compared to orbital present between the axis. Between the axis is what? dxy, dy is dz. Fine. Now how that the the crystal field theory overcome the valence bond theory? Up to I told you that D1, D2, D3 system, irrespective of the ligand, no problem. Electrons are going to fill T2G level. If D4 only, problem starts. The D4 means, please keep it in your mind, if delta O greater than pairing energy, delta O less than pairing energy. Delta O greater than pairing energy, low spin complex. When delta O less than pairing energy, high spin complex. I am taking example here. D4 system. 1, 2, 3, 4. Now the field is what? Strong field is present. Strong field means what? Delta O greater than pairing energy based on spectrochemical series. So obviously what? 1, 2, 3, 4 electron is going to occupy here. Therefore, it is because of delta O greater than pairing energy, electron is going to pairing, and a pairing takes place in the P2J itself. Therefore, it has two unpaired electron because only two unpaired electron is there. Suppose if it is high spin complex, weak ligand is present, what will happen? It will go here. Therefore, this is why high spin complex we have the four unpaired electrons. So, this is about the crystal field theory of octahedral complexes. So such type of questions you may expect based on the spectrochemical series. You have to go through that Cn minus CO and all very strong ligand, ammonia strong ligand, EDD strong ligand. So they may ask you that based on that, arrange increasing order of all these things. Fine. The last will be about if we go tetrahedral complex, very simple. Tetrahedral complex means what? We can say that. Look at this. Ligands. This is tetrahedral complex. I can say now. Look at this. This is X, Z, Y. Ligands are approaching between the axis. The ligands are approaching between the axis. What we can say that obviously dxy, dyz, dzx will repel more as compared to x square minus y square. That's all. You may have as the orbital goes up and the two orbitals are comes down. This is Eg. This is what P2G. Now you can say that this is 2 by 5 delta T. This is what minus 3 by 5 delta T. This T2 only I should say. This I should say as EGT only. That's all. All tetrahedral complexes are high spin complexes. That's the reason they will say delta T is equal to 4 by 9 delta. And crystal field theory explains about color of the complexes. See, from the color of the complexes, you can able to say whether strong field or weak field. Very simple. Go with that VGR, V, P, G, Y, O, R. This is the Manchin wheel. Observe that. So we can say that V, I, P, G, Y, O, R. I'm talking about observed one. This is increasing order of lambda. If the red is absorbed means, or we can say lambda is high, energy will be less. Energy less means what? It is a high spin complex is present. Suppose it absorbed violet, lambda is less. We know that energy and lambda both are is what? Inversely proportional. Therefore, energy will be what? Very high. Therefore, that belongs to what we can say as a low spin complex, strong field ligand. From the absorption and emission color, we can able to predict what we can say as a strength of the ligand. This is logic. VIP. Suppose the ligand absorb red region, complex having ligand absorb red region means the crystal field splitting pattern delta O will be less. This absorb or we can say blue or violet or indigo. We can say that delta O is very high. That means strong field ligand is present in that complex. Even we can say emission color also. From the emission color, emission means what? Whatever the absorbed color, the complementary color is what emission. Suppose it emit yellow, absorb what we can say as violet. That means strong field. That is the logic of what we can say that coordination chemistry. So that's all from my side. So I would like to say some few important points here. So we have discussed so many things about the last 1 month of time. I request you everyone those who are present here in this practice the problem as much as possible and work very hard. And we have another 20 days time is there for JEE mains exam. Today is 11. We have another 14 days time is there, and practice the problem and solve the questions of last 10 years of papers or 4 years of paper, which makes you more and more confident. And especially chemistry point of view, segregate as organic, inorganic, and physical. Read thoroughly NCERT book, especially surface chemistry, metallurgy, P block elements. Here they may ask you direct from NCERT question. So definitely I can say confidently, definitely perform the anyway. And be confident and work really sincere, dedicatedly. I hope that if you perform in the direction and practice the problem, at the same time you have the board exam also. I can suggest from my side, the board exam, you read now current third standard book thoroughly from part 1, volume 1, that means solid state 2, coordination chemistry, including uses. You read thoroughly, line by line. In part 2, alkyl halides 2, you can say that chemistry in everyday life, line by line read it. Structures, how many chiral centers, everything you observe. Don't leave single line because which helps for board exam at the same time for JEE mains also. Definitely you may perform really. I have the confidence on you. Be confident and work systematically and practice the problem. Organic chemistry, you should know the reagents, write the reagents and practice that mechanism, you practice that. Physical problem solving, take last 5 years of paper, solve the problem what they are asking from that, especially ionic equilibrium, solubility product, buffer solution, all these things. Inorganic chemistry, read thoroughly NCERT. That is more than sufficient. Definitely, I confident on you people to perform really well. So do well JEE mains exam, get the good percentile, join very good engineering college like IIT as well as NIT. Because if you perform well in JEE mains, definitely you'll perform well in advance. So all the best. Thank you so much. Thank you.